Morning, class. Sorry I can't be there this morning, but it's okay. We'll just do this over video, and today we're going to pick up where we left off on Friday. We are in Unit 3 talking about eliminating possibilities to solve problems. Today's problems are all going to be very similar, the same type of problems all day long, and they're called cryptarithmetic problems, and they're not exactly easy. Okay, they might not come easy to you at first, but I think with a little bit of practice, you'll understand them and you'll get them and you'll do perfectly fine. After all, things that are worthwhile are difficult. So if they were all easy problems, this class wouldn't be very fun. But the whole point is to challenge you and push you, and I think that these problems today will help push you. I'm going to go through a few examples with you today. If at any time in the video, though, you want to try the problem without hearing the answer, you can pause the video, try and work the problem out in your notes, and see how you do, and then play the video to see if you got the same thing as me. So that's always a good strategy when you're watching these videos, to practice before you hear the answer, and then go ahead and play it and see if you got the same answer as me. Alright, let's get started with the first problem here. The first problem is called Life on the Farm. And this is how it goes. Emil and Olive live on a farm with their father, Gordon. One day, Emil asked his father, "Dad, what happened to that cat we used to have?" Olive overheard this and said, "Yeah, and we used to have a horse, too." Gordon replied, "That tomcat and that old nag were no use. I traded them for our new goat." Emil said, "Hey, that sounds like a good cryptarithmetic problem. Come on, Olive, let's see if we can solve it." They wrote down, Tom plus nag equals goat. Each letter stands for a different digit, 0 through 9. No two letters stand for the same digit. Determine which digit each letter represents. Alright, and that's kind of a lot of language there. But let's go to the next slide, and I kind of laid out what this problem looks like. Alright, apologize for my sloppy handwriting, but this is what the problem looks like. We're trying to add up Tom plus nag to equal goat. And if you can see over on the right-hand side, each letter has a different possibility for which number it could be. For instance, T, it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Notice that T cannot be 10 or 25. Each letter can only be one digit, 0 through 9. The other thing that we need to know is that if T were 5, for instance, then M could not be 5 because the number can't repeat. Okay? Also, kind of along the same lines, if the T in Tom was 5, then the T in goat would also have to be 5. Okay? So we're trying to figure out what each letter represents. What number does each letter represent? Alright, so let's walk through this. I'm going to go kind of slow on this first one here. Let's walk through this step by step. The first letter that I know for sure is I know that G has to be a 1. And let me try and explain that here. I think that G has to be 1. The reason why I think that G has to be 1 is the biggest number that T could be would be 9. Okay, that's the biggest number possible for T. And if T is 9, the biggest number that N could possibly be would be 8. Okay, and 9 plus 8, those are the biggest possible answers that they could be. And 9 plus 8 only adds up to 17. So see how that G, the O then would be a 7. And I'd carry the 1, and the G would be a 1. See that? There's no way that G could be a 3, for instance, because there's no way that T plus N could add up to 30-something, right? The biggest that T plus N could add up to is 17. So that's why I know that G must be 1. And I don't know about O or N or T. I don't know about any of those yet, but I do know that G must be 1. Okay, and if the G in goat is 1, then the G in nag is also 1. So I'm going to put a 1 there by that G. Over on my letters over here, hopefully you can jot down something like this on your notes, because what I want to do is I want to eliminate possibilities. So I know that G is 1. I'm going to go ahead and circle the 1 down there by G, which means I can eliminate the 0 and the 2 and the 3 and the 4 and the 5 and the 6 and the 7 and the 8 and the 9. The other thing that I can do is I can eliminate the other letters. I know that A cannot be 1. I know that N cannot be 1. M cannot be 1. O cannot be 1. And T cannot be 1. Okay, so already now I've eliminated some possibilities. Alright, the next thing that I'm looking at as I look at this problem, and this is not easy, okay, it's kind of difficult, no doubt about it. But when I look at this O plus A equals A, the O in Tom, the A in nag, and the A in goat. O plus A equals A, okay, or, you know, something plus A equals A. Alright, so when I think about that, I think that O must have to be 0, because 0 plus A would equal A, right? 0 plus 4 is 4. 0 plus 8 is 8. So I think that the O in Tom has to be a 0. And if that O is a 0, then the O in goat also has to be a 0. So I'm going to go ahead and fill those in as 0. So on my O up here, I'm going to circle the 0, cross out the 2, 3, 4, 5, 6, 7, 8, and 9. Cross out the O and T, and M, and N, and A. Okay, I've eliminated some possibilities here. I know that the O is 0, the G is 1. Now let's look at this T plus N. T plus N. T plus N has to equal 10. Okay, so there's only so many numbers that can add up to 10. One thing is 5 plus 5 equals 10. But if T is 5, then N can't be 5, so I know that that's not the right answer. Okay, so at this point, what you can do is you can just kind of make some guesses and try it and see if it works out. And if it doesn't work out, then at least you know that that's not the answer and you can eliminate that possibility. But for me, I know that 7 plus 3 equals 10. So I'm going to go ahead and try that. I'm going to try 7 for my T and 3 for my N. And if the T in Tom is 7, then the T in goat must be 7. Okay, so I'm going to go ahead and circle those ones over here. I think T might be 7, so I'm going to eliminate the other numbers. That also means that M is not 7, and N is not 7, and A is not 7. I think that the N is 3, so I'm going to circle 3 for N. Cross out the other numbers. Okay, which means that M is not 3, A is not 3. There we go. I'm getting down to just a few possibilities now. Alright, let's look at that M up there, that M. M plus 1 has to equal 7. So that means that M must be 6. Right? Because 6 plus 1 equals 7. So M is 6. Cross out the other possibilities. I know that A can't be 6. Okay, excellent. And so now the only letter that I'm left with is A. Okay, and when I look at my possibilities for A could be 2, 4, 5, 8, or 9. As long as I choose any of those numbers, I think this problem is going to work out. So let's just choose, I think 5 is a lucky number, so I'm going to choose 5 for A. And if the A in nag is 5, then the A in goat must be 5. Okay, so I'm going to circle 5, cross out the other possibilities. There we go, I've got it. Okay, so now what I want to do is I just want to double check my answer and make sure that everything makes sense. So I'm going to start over on the right. 6 plus 1 equals 7. That makes sense. 0 plus 5 equals 5. That makes sense. And 7 plus 3 equals 10. That also makes sense. So on this particular problem, one possible solution is 706 plus 351 equals 1057. Okay, and in this particular problem, there's more than one correct answer. You could have had a couple different things, but that's how you end up with your answer. Okay, so let's try another problem. This next problem, there's only one possible answer, so it makes it a little bit trickier in some ways, but in some ways, it also makes it a little bit easier because you can eliminate more possibilities. Okay, let's look at the next problem. The next problem is called The Letter from College, and this is how it goes. The story goes that a young man away at college needed some extra cash. He sent his mother this plea. He wanted her to send the amount indicated by the following sum. Send plus more equals money. Each letter stands for a different digit, 0 through 9. No two letters stand for the same digit. How much money did the young man want? Assume that there's a decimal point between the N and the E because his mother is probably not willing to send $10,000 or so to her son on request. Alright, so when I go to the next slide, problem up. Again, I apologize for the sloppy handwriting, but this is what I've got. I've got send plus more equals money. Along the right-hand side, I just listed all of the letters that were in this problem. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8 letters in this problem. Each letter has 10 possibilities. Okay, so there's only so many possibilities. A lot of students get really, really overwhelmed when they're solving these problems. But remember that there's only 10 possibilities for each letter. So if you get stuck on a letter, the most you're going to have to try is 10 different possibilities, which you probably won't have to try 10 because I'm sure you can eliminate some of those possibilities from the start. Okay, but let's try not to get overwhelmed. Let's try this problem. The first letter that we should look at is that M out in front on money. Okay, because in the last problem we went through and realized that M has only one possible choice. M must be equal to 1. Okay, and we kind of figured that out on the last problem. So M is equal to 1. I can eliminate some possibilities then. I know that S can't be 1, and E can't be 1, and D, O, R, Y. None of those numbers can be 1. Okay, and if the M in money is 1, then the M in more must be 1. Alright, very good. Next, the next number that I personally see is this S. I know that S plus 1 has to equal 10 or more, because I need to carry this 1 out here to the M in money. Okay, so S plus 1 has to equal 10 or more. Well, there's not, S can't be 12 or 13. The biggest number that S could be is 9. And 9 plus 1 is 10. Okay, so that's what it has to be. S has to be 9. So 9 plus 1 is 10. Let me get caught up over here. I know that S must be 9. So it's not 8, it's not 7, it's not 6, 5, 4, 3, 2, or 0. And E's not 9. Cross all these possibilities out. And all this, crossing all this stuff out, it may seem like a bit of a trouble, but when you get down towards the end of the problem, it will help you so much. When you've eliminated so many of the possibilities, you'll only have 1 or 2 possibilities left. It will save you, I promise. Okay? I also know that O must be 0, so it's not 2, 3, 4, 5, 6, 7, 8, or 9. And also, E's not 0, N's not 0. I can eliminate all of those possibilities. Okay, if the O in money is 0, then the O in more must be 0. Okay, so here we get to a funny situation. When we look at the E in send, E plus 0 equals N. And that doesn't make sense. You'd think E plus 0 would equal E, right? But this is kind of a conundrum that we run into. There's no way that E plus 0 could equal N, because E plus 0 is E. The only way we could do that is if N plus R equaled something more than 10, and then we had to carry a 1 up there above the E. See that? Okay. Then this might work out. Okay, so let's try a number for E. And maybe let's just try 4. Let's try 4. Okay, so I'm going to put a 4 in here for E, which means I need a 4 down here and a 4 right there. Okay, and 1 plus 4 is 5, so the n must be 5. There we go. Now we're in another kind of sticky situation here. When we look at the n plus r has to equal 14. N plus r has to equal 14. So 5 plus what equals 14? Well, you would think it would be 9, but the problem is that I've already used 9, so r can't be 9. So again, what I figure out when I look at this long enough is I know that r must be 8. And d plus e must equal something more than 10, because then I have to carry a 1 up there above the 5. 1 plus 5 is 6. 6 plus 8 is 14. Okay, and then 1 plus 4 is 5. 9 plus 1 is 10, so on and so forth. Alright, which brings me to d and y. Okay, let me fill in some of this other information here. I know that e is 4. Cross out, cross out. I know that, what else do I know? R is 8. Okay, I know that N is 5. And I think that's all I know. Alright, so when I'm looking at this, I'm down to D and Y. And look at that. I've eliminated most of the possibilities for D and Y. Here's the deal, though, is D plus 4 has to equal a number bigger than 10. So D, the biggest number that D could be is 7. Okay? And 7 plus 4 is only 11. Here's the problem, though, is that 1 has already been used. M is 1. Dang it. Not quite going to work out. Okay, so let's change some numbers here. See, this is how eliminating possibilities works, is you try some possibilities and see if they work. And if they don't work, then you try something different. Let's say that E isn't 4. Let's say that E is 5. Okay, now we have 7 plus 5 isn't 11. Now that's 12. Carry the 1. N can't be 5 anymore. Let's say N is 6. Here we go. 1 plus 6 is 7. 7 plus 8 is 15. So again, this E isn't 4 anymore. It's 15. Carry the 1. This E up here isn't 4. It must be a 5. 1 plus 5 is 6. 6 plus 0 is 6. And the N up on send is 6, so it's a good thing that the N down here in money is 6. So, by gosh, I think that works. Okay? I think that 9,567 plus 1,085 equals 10,652. Let's just go through it one more time, step by step, and make sure that it works. 7 plus 5 is 12. Carry the 1. 1 plus 6 is 7. 7 plus 8 is 15. carry the 1. 1 plus 5 is 6. 6 plus 0 is 6. 9 plus 1 is 10. Carry the 1. Excellent work. So that's the solution to this problem. And it's not always going to work out perfectly. As we saw in this example, we found out that E could not be 4. E had to be 5. Okay, so let's try one more example. In this next example, it's called here she comes, and it's here plus she equals comes. And this problem is the same rules. Each letter has to be a digit, 0 through 9. No two letters can be the same digit. Same rules that we've been playing all day. Again, this is a good chance for you to pause the video, try this one out on your own, see if you can do it all on your own, and then watch the video and see how I did it. Okay? So I'm going to go to the next screen. Again, it's a good idea to pause it and try it. But I'm going to go ahead and solve this thing. Okay. As I'm working here, again, the first thing that I look at is this C out front. I know that that C has to be a 1. It can't be anything bigger than that. C has to be a 1. Let me eliminate some possibilities here. Give me just a moment. Alright. Next then, I look at that H, and I know that H plus nothing has to equal 10 or bigger. Okay, so that's tough to do because the biggest number H could be is a 9. So I'm going to go ahead and assume that H must be 9. H is 9. Alright, and if the H in here is 9, then the H in she is also 9. So we know that. I also know that I must be carrying a 1 up here at the top because 1 plus 9 equals 10. Okay, so the O must be 0. So I know that. I know O must be 0. There we go. It's coming along now. Okay, now I'm to the part where I'm not exactly sure where to go next. So what I need to do is I just need to try some different numbers and see if they work or not. I had to do some trial and error. Sometimes it might work, sometimes it doesn't work. Okay, so let's look at E. There's 1, 2, 3, 4 E's. So if I could figure out E, I bet I could figure out the rest of this problem. Let's make a guess for E. Okay, last time E was 5. So let's try that again, see if it works again. Let's try E as 5. Okay, and already I can see that that's not going to work because 5 plus 5 would equal 0, which means S would have to be 0, and S can't be 0 because O is already 0, so that's not going to work. E can't be 5. So let me get my eraser out. E's not 5, I know that. Okay, so over on my chart over here, I know that E can't be 5. Eliminate that possibility. Okay, let's try 4. Maybe E is 4. That's worth a try. Okay, 4 plus 4 then would be 8. So S might be 8. That means this S is 8. Okay, that looks good so far. Then R plus 9 has to equal 4. R plus 9 has to equal 4. That means R must be 5. Because 5 plus 9 is 14. Then I could carry a 1 over here. 1 plus 4 is 5. 5 plus 8 is 13. Carry the 1, which I needed. Hey, 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 it looks like we have a winner here. Let's double check our answer really quick. Go through it and make sure that it makes sense. If E is 4, 4 plus 4 is 8. S must be 8. Okay? Then 5 plus 9 is 14. Carry the 1. 1 plus 4 is 5. 5 plus 8 is 13. Carry the 1. 1 plus 9 is 10. Carry the 1. So it looks like there's our answer. I'm going to go ahead and fill in my chart here real quick. I found my answer. Notice I didn't get my answer right on the first try. First I thought that E was 5. Okay, and so I did a little bit of math and figured out that there's no way E could have been 5, so I eliminated 5 from the possibilities. And I just tried a different number. And don't be afraid to just do some trial and error and try different numbers out and see if you can come up with the right one. Alright, it looks like I finished that problem. The next slide is your homework problem. Okay, and this one you're going to have to try all on your own. If you want to work with a partner to solve this one, that's okay. You can work with a partner. The next one is called Wow Wow So Cook. Okay, and it goes like this. Danae was having an argument with her roommate Frankie about whether or not Frankie could cook. After arguing for a while, Danae said, "Wow, wow, so cook." Frankie, who was a math teacher, noticed that what Danae said might be a cryptarithmetic problem. She sat down to work on it, and Danae ended up cooking dinner. Each letter in the cryptarithmetic problem stands for a different digit. Hint, K equals 9. Okay, so they're giving you K. That's good. I know that K equals 9. I also know that C got to equal 1. So there's only 3 letters left. A W, an O, and an S. Those are the only 3 letters that you have to figure out. This problem looks really, really simple, but it's a little trickier than you think, so you got to be very careful with it. But you only have 3 letters to figure out, W, O, and S. See if you can solve this problem. You don't need to write any paragraphs today. Just solve this problem, find out what W equals, what O equals, and what S equals. Good luck. I hope this comes easy to you. If you need to go back and watch this video again, that's no problem. Thank you, and I will see you soon. Bye.